Okay, we're going to look at the work, 656, avoiding the mess. If we look back at the problem that we did at the beginning, we used the equal values method, which led to fractions and decimals and lots of opportunities to get confused. So let's see if we can get away from that. A new method called the substitution method can help you solve the system in the previous problem without using fractions. So that's pretty cool. The method is outlined below. And it shows the two equations, and it shows that y is equal to negative x minus 7, and it circles those for some reason. So let's try to figure out why it's drawing attention to that fact. If y is equal to negative x minus 7, then does negative x minus 7 equal y? I think that's only fair. Yeah, sure. That is, can you switch the y and the negative x minus 7? You can, because if a is equal to b, then b must be equal to a. Yes, because I'm just going to write that exactly. If a equals b, then b also equals a. This is called the symmetrical property. And all that means is that you can reverse any equation. You can put what's on the left side on the right and vice versa. We all know that. Since you know that y equals negative x minus 7, can you replace the y in the second equation with the negative x minus 7 from the top equation? I guess if this is equal to y, and we've said that it's equal to y, then whenever we see a y, we can put this instead of the y. You can replace it. Yes, because the negative x minus 7 is equal to y. So it can replace y. And it's sort of related to what we said before. If a is equal to b, then b is equal to a. So if this is equal to this, then wherever we see this, we can replace it with this. Okay, so once you replace the y in the second equation with negative x minus 7, you have an equation with only one variable as shown below. This is called substitution. So this is the substitution method, because you are substituting for or replacing y with an expression that it equals, in this case the expression being negative x minus 7. Solve this new equation for x and then use that result to find y in either of the original equations. Show all steps. Okay, so we've got this equation because we replaced the y with negative x minus 7. So it's 5 times negative x minus 7 plus 3x equals negative 13, which admittedly isn't pretty, but it's not that bad either. So the first thing we're going to do is we're going to distribute. We're going to distribute the 5. So 5 times negative x is negative 5x. 5 times negative 7 is minus 35. Oops, better write the right thing. And then plus 3x. And all that is equal to negative 13. Okay? So negative 5x minus 35 plus 3x equals negative 13. Next, I'm going to combine like terms. I'm going to combine this negative 5x with this plus 3x. Combine. Combine like terms. That gets us negative 5x plus 3x, which is negative 2x minus 35 is equal to negative 13. Now we're trying to get x alone, so we'll add 35 to both sides. And that will get us negative 2x is equal to, we're adding 35, so negative 13 plus 35, it's good to have an equal sign. Negative 13 plus 35 should be 22. You can check it in decimals if you want. Negative 13 plus 35. 22 is correct. Okay. So negative 2x equals 22, so we'll divide by negative 2 on both sides. And that will get us 22 divided by negative 2. I'm not saying to be over-reliant on decimals, but it's not a bad idea to at least check. 22 divided by negative 2 I think will be negative 11. But let's take a look. Negative 11 is correct. It's always good to at least validate your work. Okay, so x is equal to negative 11. All right, let's just check. Is that the same thing we got earlier? It is. We got it right here. Negative 11 equals x. The neat thing, though, is that this time it was a lot easier. There were no fractions or decimals, so I'm liking this substitution method. Okay, but now we need to use x equals 11 in either of the two equations to find y. I like this one. I like it because it's simple. So I'm going to write it. Y is equal to negative x minus 7. And then I'm going to substitute in the negative 11. So y is equal to parentheses negative 11. Oh, wait, sorry, negative. Whew, look at that, negative 11. Because it's negative x, and x is negative 11. That's important to notice that. All right, now negative 11 would be positive 11. So y is equal to 11 minus 7. So y is equal to 4. Our final solution is x is negative 11. So we go negative 11, comma 4. All right, that's the exact same solution that we found earlier. But I think you will probably agree that the math on this was much simpler. So the key is recognizing when you can substitute. If you substitute in, then you still have some positive and negative work, but no fractions and no decimals. And I think we all appreciate that. So let's hear it for the substitution method. Yay!